They are the same things depending on what you have. The average rate of change for f of x. Okay, guys? Average rate of change is not a derivative, but you're close. It's the slope, on the interval. Let's call it AB. Any function, that function itself might be a rate. So you have to read the problems carefully. Like the first problem, that's confusing because it is a rate. But it's f of b minus f of a all over b minus a. What if it's the average rate of change in your notes? No. This was like last minute, but you should have a notebook where you keep important things like this. Of f prime of x, a to b. What does that look like? Well, that's f prime of b minus f prime of a all over b minus a. So in the first problem, you are given that capital F of t is a rate, but that's okay. You can still find the average rate of change of a rate. It doesn't matter. It's some function. So what if I wanted the average value? And I don't believe we've done that yet, but we're going to do it right now. The average value of f of x on the interval a to b is the integral of a from a to b of f of x dx we'll just wait for that to stop. Dx over b minus a. I didn't do it. I have little gremlins today. Well, that could be straighter. Okay, guys. What is the average value of f prime of x on a to b? Okay. Next. What's the average value of the derivative? Well, it's the integral of f prime of x from a to b all over b minus a. But you know what? I can do that. Here, what's the integral of f prime? Yeah, it's f of x evaluated at a and b over b minus a, which is equal to f of b minus f of a all over b minus a. We know what that is. If you're asked for the average value of a derivative, this is the average rate of change of the function. Does that make sense? They are connected. Depends on what you have. So you have to read the problem carefully. And it's confusing. If you find the average value of a derivative, then it's the function at b minus function at a. But I recognize that. That's the average rate of change. So you can see the connection of f. This is f prime. The average value of f, that is the integral of capital F of x. Do you want to make it capital? F of b, you can. Minus capital F of a. It still looks like an average rate of change, doesn't it? That's the average rate of change of the antiderivative. You want me to give you an example in particular? Yes?
What's the integral of 4 sine t over 2? Isn't it negative cosine for sine?
It's question 1. It's calculator problem. Okay. What if I find the average velocity if I'm given the velocities, okay guys, if I'm given the velocities from t1 to t2 of v of t dt divided by t2 minus t1. That's the average velocity. average? A. Part A. No, I'm just trying to connect these two. Part B is, let's go ahead and integrate that. What is the integral of v of t? What's the antiderivative of the velocity? That position. So it's s of t evaluated at t1, t2, divided by t2 minus t1. So that's s of t2 minus s of t1 over t2 minus t1. That's because that's not going to change. It's t2 minus t1. That's the interval. Well, if I'm given the velocities to find the average velocity, you guys are going to miss this. I integrate. If I'm given the velocity, and I want the average velocities, I integrate. If I'm given the position, then I want the average velocity. It's just the average rate of change. And there it is. I just showed it to you. This is the average rate of change of the position. This is the average value of the velocity. I'll write it this way. And this is equal to the average rate of change. They're the same. Depends on what you got. It took me a couple years to realize that of the position. Very nice little subtlety. So if you want the average rate of change and you're given the original function, it's going to be slope. If you want the average rate of change of the velocity and you're given the velocity, they match, then you integrate. If you want a quick, simple little thing. Now you should be ready to work the problems. This is due tomorrow. You have time in class. You work on it with a partner. 15 minutes. I've got a smart board with my smart board has answers. I didn't bring it up though. Sure. Except I didn't tell you what year that was. No. The one below is 2011. And then I did 2012. Look how much is on here. You guys more than half your exam is AB. See how easy or hard this is now. Give it a try. I have to turn it in tomorrow, so put that away, whatever it is. No, you're going to do it together. It's not divided. Rate the velocity. Oh, wait. Yeah, but you're not going to have that on the exam. From 0 to 5.19552 of the V of t by the fundamental theorem of calculus, that's going to be my position evaluated at these places. So this integral, and now I could label that T1 or whatever I want, is equal to S of 5.19552 minus S of 0. But S of 0 was 6, wasn't it? Oh, sorry, S of 0 is 2. So you're going to add 2 plus this integral, and you're going to use your calculator to do it, equals your position at that time. That's a classic trick. Yes, it is a classic trick using the fundamental theorem of calculus. So they said it's 2. That's exactly what I did. From 0 to b, this is the b, 5.19552. And you just integrate it on your calculator. Did you use the absolute value? That's why. Because you want the distance you travel. So distance, not displacement, is equal to the integral of the absolute value of v of t dt. These are really good questions. Because what you do is you integrate from 0 to b. B is this, right? Of v of t. I am. That's the fundamental theorem of calculus. evaluated at 0 and b. Yeah, and this will be on your exam this year. And they told me, they called it X. Okay, X. That's 2. They gave that to you. They always have to give you that initial position. Otherwise, you can think of it as X of B is equal to your starting position plus the integral from 0 to B of V of t dt. Where does it come from? It comes from that line right there. I like to know where it comes from. Also, you're not starting at the origin. You're starting someplace else. So you got to add in the 2. Yep. Just the answers? Can you get a lot of points on this problem? Yes, you score quite a bit higher on this than the AB students. About 2 points higher, 2 to 3 points higher. Wait a minute, let me answer this question. Because it's asking, is the traffic flow increasing? How do you know if this function is increasing? It doesn't matter. I'm asking if the flow is increasing or decreasing. Yeah. What was the next question? This one? That one. And as you can see that, with the class opener we did last Friday, was out of the homework. The homework is not easy. You need to practice. I'll have to wear this shirt again when we get to use substitutions. Not this year. You're right. We've done use subs. No, because we didn't start integration until here. You could do use substitutions for derivatives, but I don't like that. On the third problem, B is where you have to interpret your integral. You need, it's warm by 16 degrees Fahrenheit, and you need the interval, and you need the units. I've never seen it with fewer than 3 things. I've always seen it with 3. So to do D, it's still that same fundamental theorem, and we will practice till we get this. If I integrate from 20 to 25 of W prime of t, then I get W of t evaluated at 20 and 25, and I know one of those is the 20, W of 25, right, minus W of 20 by the fundamental theorem of calculus. So it's a calculator. So W of 25, if I add W of 20 to both sides, plus this integral. And there you go. Okay, how do you know a trapezoid formula? Because what are you going to do on the exam if you don't remember it? No, you're going to figure it out. So I have area of the first triangle, which is 1/2, base 2 times the height, plus the area of the second triangle. 1/2, height times B1, and if I factor out 1/2 H, B1 plus B2. Or I could think of it this way. B1 plus B2 divided by 2. It's an average of the bases. If it's going to take years, you're doing it wrong. Yeah. How many trapezoids do you need?
Four. There's a lot of trapezoids.
It's worth like 3 points, I think.
Well, can I do it on the exam?
There it is. It's worth 3 points. It says Riemann. It doesn't say.
I don't know how that works.
Oh, which problem are we looking at?
Four.
I got that too.
That's all right. 52.5.
Okay, this begs the question. Do you have to do the arithmetic? No. You will get full credit with that. But if you come up with 52.95 without this work in between, you'll get no credit. Now, some people did triangles and rectangles, which ends up being a trapezoid, and so they did give credit for that. It does ask specifically for the trapezoidal rule. I was kind of surprised, but there was a lot of discussion on that at the reading that year. If you don't show what you added, if you go 126 divided by 6, that won't get it. You've got to show what your bases were. Oh, if I just draw the picture. Yeah. Where do they ask for that? This one? And the function's increasing. So if you do a left Riemann sum, I would say that the function's increasing. It's not the concavity. You don't believe me? Draw one with concavity. Left Riemann sum is still under. It's the fact that the function's increasing. But I have to draw the pictures because I never remember. The last one? You like doing these? They're kind of neat. Are they doable? Can you average 7? If you can average 6 to 7, you're looking at a 5. And the more you do, this was just 2 years. I got 4 problems out of 2 years.
Can you show me the answers for the fourth?
Yeah. Notice again they ask for the meaning of the expression. There are 3 things. 23, the fact that it's negative is a drop with the units, time interval. So if you end up with negatives, you better say it's a decrease. I graded this one. Is this the tea and biscuits? Yeah. That one wasn't too bad to grade. Look at that. Just on another piece of paper. And it wouldn't hurt you to do some of the problems out of the textbook, especially the word problems.